Everyone, welcome to 5.2 day 1, and today in this lesson we're going to be taking a look at the inverse of functions. In 5.1 we just learned about quadratic functions and the transformations that deal with that. So we're going to take a look at the inverse of a function and what inverse means. So let's start from the basics here and take a look at the notes here. Understanding functions is that a relation, as you may have learned in elementary school or middle school, a relation is a pairing of an elementary element which has an x value and a y value. So that would be a relation. And we call the x value the domain or the input, and we call the y value the range or the output. So a function is a special type of relation that pairs every input with exactly one output. So the input cannot be repeated in order for this function to be a function. And you can use such things like a vertical test to see if, for example, if you use the vertical line test and you only hit one point at a time only, that would be a function. Such as this is also a function. But if you look at this is not a function because it's hitting more than one place in multiple places. So what is a one-to-one function? A one-to-one function is that there cannot be an output that is used more than once in the function's pairings. So the one-to-one function is that you can only have one number for the x value paired with the one number in a y value. Okay. A many-to-one function is that at least one of the output is repeated, is used more than once. So if for example, the 2's are repeated here. So this is a many-to-one function. And to understand what inverse is, that the most simple way to put it is if you have a pair of numbers, you switch the x and the y value, that creates the inverse. So if every one of these are switched, you will have the inverse function. And that's what basically inverse is, switching the x and y value. And the key point is that the inverse of a function may or may not be another function. So just because a function is an inverse is a function, it does not mean that the inverse is going to be a function. So it has to meet a certain criteria. So if the inverse of a function is not a function, then it is simply just an inverse relation. So we don't have a function, but it can be just a relation. And let's take a look at the first example. Try it. To complete the diagram for the inverse of the function. So again, to find the inverse of the function, we simply switch the x and y values. So the first one is already done. So we have -2, -4, and then -3. Switching it will be 0 here. And then 2, 1, and then 1, 4. So if we look at the function, is the function a one-to-one or many-to-one? So if you look at the function right here, none of the values in the range are repeated. So therefore, the function is actually a one-to-one because no output is repeated. So that's a one-to-one. And C is the inverse of the function, also a function. So if we look at the inverse of the function, also a function, we would actually look at the x, the domain. Remember, in order for a function to be a function, the input cannot, or domain cannot be repeated. So if we look at this list of number, none of it is repeated. So therefore, yes, the inverse is a function because the input is not repeated. Okay, so that answers the questions in this example. Let's take a look at another example. Here's another relation. Complete the diagram or for the inverse. So we again switch it. That will be -2, -4, -3, 0, and then 2, 1, and 2, 4. So is the function a one-to-one or a many-to-one? So if we look at the function itself, notice that 2 is repeated. So this would be a many-to-one because the output is repeated. Second question, is the inverse also a function? So if we look at the inverse and we look at the inverse, which is here, we look at the input, notice that 2 is actually repeated. It's being used twice. So this is not a function. So no, because the input is repeated. So no, this is not a, so we are again, look at the domain here. It is used more than once. It's going to 2 output. So therefore, this is not a function. The next example, we're going to refer back to 1a. 1a is over here, and we're going to take a look at that problem. It says the function is given by those 4 points, and what is the inverse function? So we're going to, again, switch the x and y to give us the inverse. So we'll have -3, 0, 2, 1, and 1, 4. So that's switching the input and the output. And part B, graph the inverse. So we're going to have -2, -4, -3, 0, 2, 1, and 1, 4. So what do you guys notice about the points that are graphed originally, which is in black, and the new points that we graphed? So that will be the next question. What do you guys observe about the graph of the function and the inverse in relation to the line y equals x? So here's the line y equals x, the dotted line here. This is the mirror right here. So if you actually notice, this is a mirror image of the original. So the new points are original points reflected across this line y equals x. So that would be the observation that you want to make. So the graph, the graphed points are reflections across the line y equals x. So it's a mirror image across that line. And so discussion question, what must be true about a function if its inverse is not a function? So remember, if the inverse is not a function, then you must have something that is kind of like this. When you use the vertical test, it fails in multiple places. So that's when the input is repeated. So that means the inverse is a many-to-one function, which means here is the function, here is the inverse. So if we have the input, this is the domain, this is the range. So if the range is repeated in the function, then that means when you switch the numbers, then the input is going to be repeated. So that's what causes a function to be not a function. So if the inverse is not a function, which means here the input is repeated, but that means that going back, if you switch it, that means the output here must be repeated. So that means must be a many-to-one function over here for the original in order for the inverse to be not a function. Hopefully that helps. And so that's the end of day 1, and go ahead and get started with your homework on Google Classroom, and have a nice day.